I think that we are going to begin. If all of us, we are ready for this new experience. So, they gave me here a list for this oral block of some presentations, and we are going to begin for pyrolysis compound-specific isotopic analysis of soil organic matter, size fractions, and therefore vegetation covers. I think that is this one. And who is presenting this one?
For vegetation cover and pyrolysis. And the other was isotopic signature in a specific compound related directly by pyrolysis analysis, carbon and hydrogen. The first part we can see the chemometric analysis of soil fraction, the core fraction, and the fine fraction. Also say that the samples were taken in Doñana National Park to west of Spain, and the four types of vegetation cover. The vegetation were Scartus US, Pterina clinis, EA, Pinus guinea, and Alimina limicolium, AA. Okay. In chemometric analysis, we can say in a core fraction that the principal family in this fraction were lignin compounds and aromatic and polysaccharide compounds. In the contrast, the fine fraction, the main compound, main family, were aromatic and specific compounds and liquid compounds. The result showed that the evolution of the organic matter in the core fraction, this organic matter could be original matter, and the prime fraction showed a high evolved organic matter. The other part of the study was the isotope study by elemental analyzer IRMS. We can obtain the delta value of nitrogen, carbon by combustion, and the barium and oxygen by pyrolysis. In this part, we can view as all sample in a fine and core fraction. In carbon, there is origin at C3 plant. The problem with the oxygen isotope was that we don't remove the mineral part or the mineral matrix into the soil. The new technique used in this work has been a pyrolysis compound-specific analysis. In this part, inside, we can say the delta value of carbon in 3 panels. case, in this slide, we can see as both the liquid compounds present a slow value. My computer is not adapted with this. It's only in the same. Yeah, we need to. Okay. In a polysaccharide, the polysaccharide delta carbon value was higher pursuit.
Oh, sorry. Yes.
No problem. Okay, the next slide was the delta value of hydrogen. In this case, the value was similar to the values were similar, sorry, to the delta carbon isotope. Showed that the lignin compound, alkane compound presented the delta value more or less. This result indicates that the high activity of microorganisms into the conclusion of this work was where the combination of traditional techniques of the study of soil organic matter, pyrolysis analysis, with new infinite analytical pyrolysis technique, PCC, open a new possibility and window of information in soil organic matter. Our finding point to the offering of more or less complex processes that affect soil organic matter chemical characteristics, whereas the gold fraction resembles the chemical structure of the above vegetation. Its soil organic matter memory is less definite in the fine fractures, so probably due to biologically mediated chemical conversion, addition of a selective preservation of and soil organic matter, gold, IRMS, CCS are informative about the relevant plant physiological processes, organic matter sources, and degree of organic matter evolution, and also about water, state, and climate condition or weather conditions in which the organic matter was processed.
Okay. So sorry. Mm-hmm. Not at all. Thank you very much. Thank you very much. Okay. So if anyone has, yeah, in a little bit with a delay, but okay. So have anyone a question, please? No. No? Okay, I think that I recuperate my voice here with this avatar, so thank you so much. I was going to ask you only one thing, Nika. Why did you begin with this research? Is it a personal question or? Yeah, well, can you summarize? Thank you so much. So I think that we are just going to pass to the next presentation. That is Saru. So we are going, if we don't fight, we are going to your poster, to your presentation. Let's see what happens, because this is like the subway, you know. So I am trying to go there. This guy is there, but I will try to be, oh, look at that one. Yes, flying. There is no gentlemen's anymore, Taru. So, okay, let me see. I will put here and just turn around. Ta-ta-chan. There. I am now looking at your poster. And I think that someone is going to put just close to you so they can record your presentation. Mm-hmm. So please, Taro, just begin with crowdsourcing data on decomposition with the help of schools. T for service, for science. Yes, okay.
This first slide here uses feedback, and I would like to explain. for measuring decomposition. So decomposition of soil organic matter means basically that the more complicated structures are turned into more stable ones. So first we are decomposing the easily decomposable sugars, then more difficult compounds, such as cellulose, and last some lignin. And here on the slide you can see green tea, which is representing sugars or easily becomes material, and rhombus, which is representing a more stable organ matter. And with these two t-tags, we can measure decomposition in salts. So basically, we bury these in salts for 3 months. We rate them before and after, and then we can calculate the decomposition as well as the stabilized index. And we are doing this in many long-term experiments as well as on lab experiments. And together with schools, we would like to spread this method to all community schools.
Well, we have a.
On this slide over here, you see how subgroups can collect this data by these characters. So in here we have had a subgroup from Austria. They have waited t-tags before, they are eating them in the soil for 3 months, and afterwards they are digging them out, drying them, and weighing them again. And thereby we can calculate the decomposition and step by step how to do the experiment. And to give you an example of automation is included in this lesson, here is one explanatory picture. So we want to explain what affects the decomposition in nature. So for example, if you add fertilizer in the soil, you can speed up the decomposition because microbes the resources. If you apply the soil, the decomposition will get slower because microbes need oxygen to breathe. And if the soil gets a lot colder, the decomposition will also slow down. And in this lesson plan, you just get the discussion process, and I gave how to explain to the students how decomposition is affected by the environment and participate. And if you would like to participate in this experiment, we have 2 sources of information that you can download. We have one article in Methods of Approaching Evolution, which is explaining the method. And now also we have this lesson plan, the natural science explaining step by step the background and the procedure of the then we class the method. And
hello? I think so.
follow us and thereby spread the word and join I would like to open for questions.
Okay, thank you so much, Taro. I can see that your talk is making excitement between the public, and they are jumping here and flying. I haven't seen this in my life, like a chairperson, really. Also, you know, there is an invisible person just going on there. First, yes, I thought that it was just a fly, or I don't know. Now I can realize. So thank you so much, Taro. So anyone wants to make any question, please jumping. For example, Jose Alfonso, do you have any interesting question, Jose Alfonso, or not?
Well, yes. One close to the other. But in your project, the students weight the bags and the
Yes. So the students can do this better. This can easily be done on a pocket scale, which has with 0.00, and this is like an easy experiment with the students to do. It's not difficult at all.
Okay. So, can you hear me, public? No, they cannot. They cannot. Yeah, I can see. Okay, no, don't worry, but why did you take this off? Because it was an interference for me? No, I think that they cannot, really. I just lost control of the session. So can you ask to the people if they want to ask something or... Really? Once in a while I can hear something, but yeah. So no questions. Danny, can you ask the people? Because I think that they can listen to you. These people that are here in the room. So I don't know if someone has any question. Yeah, go. Let's go into the next presentation. That is Agustin, you know, is restoration simulating soil erosion.
Well,
control.
my name is Agustin Bermejo. I work as I listen to me speak. Is there any problem with the sound?
No, I can hear you perfectly. Me and the 30 persons that we have in the room.
Well, I said that I work as a director in a technician company, the technician department of Montevivo company, and I'm the owner of the third part of this company too. Well, we work in the ambit of environmental services, and one of the most important tasks we run is erosion control in degraded lands by using different technologies. Our main experience turns around post-fire erosion. Well, as you know, after forest fires, soil gets unprotected because of the loss of vegetal cover protection and sometimes the disaggregation of soil particles. We try to protect the soil and keep it on the hill slopes by the construction of barriers, mulching, seedling, etc. In the PowerPoint, this PowerPoint we have ahead, we have present, or you can see how we have used three kinds of industrial remains. Or when I say industrial remains, I am speaking about waste. I don't know if it's the right expression. Waste remains, industrial remains. These three industrial remains are cellulose fibers, diatom lands, and biomass ashes. With these three components, we manufacture a new model of barrier to use in erosion control. Our idea in the beginning of the project was the use of these barriers in post-fire erosion control. But now we think that they could be used in agricultural restoration and in other lands degraded because because of human activities, as mining or building, the presentation takes more than 5 minutes. Then I think you can visit this presentation after and see it slowly. And I'm here for answer all your questions about this.
So, Agustin, we had a little problem, and it's that you didn't pass the slides meanwhile you were talking.
No, I have not been passing the slides.
No slides. Okay.
No. Yes, there is slides. Look, this is the slides. Yes. I was trying to say that the presentation takes more than 5 minutes, and I will pass slides and speak about how is the presentation structured. Okay. From the beginning, our overall goal was to design a new model of barrier to improve erosion control after wildfire. And in this slide, you can see some of the most important specific goals that have been next. The immediate availability of prefabricated barriers for installation in the first weeks after the development of a model of barriers fast to install, allowing the restoration of more vulnerable areas in short time, to retain the soil on the slopes as much as possible by installing a new model of barrier, the availability of water in the soil, increasing holding capacity and reducing evaporation. And other specific goals have been create a product able to support the weight of sediment and acids retained and stand at least until the new plant cover consolidate. Get a cheap product to soften the economic burden of fire restoration, and get a product based in environmental area without side effects. In the following slides, you can now the procedure you can see the results. As I said before, the three definitive components have been remains from paper factories, diatom lamps from beer factory, and flying ashes from electric biomass. The definitive material is very light, is easy to carry, easy to manufacture, is easy to install, and improve conditions for plants consolidation. You can see 3 or 4 graphic samples like this: soil temperature evolution among 2 months, using the barrier or but no. You can see the weight bearing too, and finally you can find restoration simulating, where as conclusion you can see that the cost of this method is lower than traditional ways to take the restoration of forest fire soil erosion. Thank you.
Agustin, can you hear me?
Yes, I can hear you. I said that I have one question.
But me first. I like to know.
Does anybody have understand me?
Yes, we have understood you, but now Tani wants to ask you a question, and if you don't mind, you can listen to her and then you answer.
It's okay?
Okay.
Okay. How long can this type of structure be kept in the field?
Yes. This one slide. I'm trying to arrive to this slide here. This is. Can you see the table in the slide?
Yeah.
Yeah.
Well, I'm going nearly close to the table. Well, one moment, please. Well, here, Tani, you can see that in different degrees of slope, we have checked or we have tested 3 barriers in each slope. In example, in 100% slope, you can see that the barrier 1 has been 12 months in the field. The second barrier has been 13 months in the field, and the last barrier has been 13 months in the field too.
Okay, because later they were degraded or why?
Yes. Later of this, the weight of the sediments and the acids retained, and the moisture and the weather, generally the weather, degrade the barrier, and the barrier disappears. The barrier is degraded and become a part of the soil.
Okay, thank you.
Okay, so thank you so much, Agustin. And we are going to the last of this block, that is Julio, the Julio presentation.
Fine, well, thanks so much. As you said, my name is Julio and I'm carrying out my PhD in the University of Córdoba. Well, first of all, it is necessary to introduce the context of this application. It is known the great variety of problems that erosion studies imply, especially when autonomous electronic equipment are involved. From electronic or energy supplies failures to vandalism and burglary, there are different sources of gaps in dataset that can take place, causing troubles in the later analysis of the data. Because of that, the main objective of this application is to improve the quality of measurement system in order to enable a visual analysis of the measurement conditions and improve the sampling programs. Okay, the core of the system is a digital video recorder connected to a control circuit, a router, and a 3G modem. The control circuits enable the power supply of 3 video cameras placed around the measuring station, so they are controlled by an ultrasonic level sensor. If a upper threshold is measured, the cameras are turned on and the video signal is processed by the DVR. But when the lower threshold is measured, the cameras are turned off. Therefore, the cameras are consuming electrical energy only if it is necessary, lessening the lifespan of the batteries. The function of the modem is to enable a communication with a remote PC, so this is able to access the recorded video and turn it on the cameras. The whole system is powered by a solar energy set. In addition, a level tape is placed at the measurement area to provide visual confirmation of the level sensor measure. The system was tested in 2 different ways. Firstly, the image quality was tested in laboratory, and secondly, field tests were used to prove the correct operation of the control system. About the obtained results, the control system operates properly, turning on the cameras when more than 5 centimeters level are measured, and turning them off when less than 1 centimeter is measured. In the same way, the remote access has been checked, so a remote PC is able to access to the system through Internet Explorer and control the cameras. Using this system, 2 sources of errors in datasets have been detected. In both cases, the sample taker was activated, but no sample was taken. In the first case, the level sensor detected the movement of a small animal, as it can be seen in the picture. And in the second one, the event did not generate runoff. Instead, the signal was due to rainfall accumulated for an intense pulse close to the fume and detected by the level sensor. Well, in conclusion, the main advantages of this system are its low cost, above 600 euros, and the possibility of storing visual information of the measurement episodes and checking the status of the measuring station anywhere and anytime. However, the main problem is the erratic behavior of the power source, so the future lines of work will be in this way, improving the stability of the solar energy system. This is all.
Okay, thank you so much. And I think that this is one of the best talk that we could follow here, because we have been doing adjustment with the computers, with the microphone. So I think that we are getting there, really. Thank you so much to all of you. So now have anyone any question? We Avatars community, we are so shy. After Tani was telling us that one of the advantage of these things is that everyone just feel more comfortable. Everyone just say what they want, how they want.
We have to refuse the hypothesis.
Yes, I think that if I do a simple statistical test, Tani, you are not right. Anyway, so I really like this application of this type of tool, you know, this video camera, because really I think that one of the problems that we have is to measure things, to have really good measurements so we can model in things and estimate things much better. And I can see in images, in image analysis, a real tool for this community. So everyone is approaching there is someone appearing now. Huh? Here, okay. Oh, so be ready, Tani has a question
Julio,
here.
can you hear me?
Yes.
Okay. In your opinion, what is the main usefulness of this system compared to other systems? Compare other systems that you can buy in a company.
Okay. Well, as it is, it was made by yourself. It is exactly we need, so we can configure it to our concrete needs, and we can make that the system control exactly we want control.
Okay. Thank you.
Thank you to all of you to be here. And I think that this first block is finished, because I have been looking around, but I don't see Joao. So for another time, we just look at the presentation, and thank you so much.
Okay. Hello all. I'm now the new chairman of this very real virtual session. Thank you, Ana Maria, for showing me how it works. I think we can start directly with virtual and real Agatha, that she will tell us about her avatar's remarks on the carbon input threshold and the sloping croplands. The problem is, I hope, Agatha, you know where your presentation is. Okay, let's follow soil 1. Soil 1, because this is Agatha, and she will find where we have to go to look at her presentation. The only problem is that I have to find soil 1. Here. Okay, we are here. I will stand. Jose, did you copy me? No, soil 21 is the same, more or less like me. So I'm standing beside of the of this presentation, and I will wink. No, that's now I'm clapping. Oh, no, I'm winking. So do you see it? Hello. So let's come, everybody. And Agatha, it's yours now.
Okay, thank you very much. So, good afternoon, everybody. I'm the avatar of Agatha Novara from the University of Palermo. In this very short presentation, I will focus our attention on carbon input threshold in the sloping cropland. We have to remember that in the sloping cropland, in the last year, agro-environmental...
I think
sorry.
Your microphone is off because everybody's hearing you through my microphone.
I'm saying that in the sloping croplands, agro-environmental measure in the last year has been proposed for erosion control through the soil vegetation cover and carbon increase. The aim of this work was to understand if soil organic carbon erosion losses under agro-environmental measure can be higher than conventional tillage. Now, okay. Perfect. So, in this graph, I'll try to summarize the effect of land management conversion. But before, I want to say here that we can see these two questions. So, the aim was to answer also if are stock erosion losses under environmental measure higher than conventional tillage. So, this is our question. And so I say that in this graph we have summarized the effect of land management conversion from conventional tillage to agro-environmental measure. After the conversion, the soil organic carbon increase and the erosion rate is reduced. Therefore, the loss of sock decreased too. In the time 3, the sock is increasing and consequently the loss of soil organic carbon increased too. The question now is which is the maximum carbon input that doesn't lead to higher sock losses in agro-environmental measure than conventional tillage. One moment, okay, because the slide are no? Perfect. So, the sock loss in conventional tillage have to be lower than sock losses in agro-environmental measure, and the sock loss can be estimated with the following equation, where A is the erosion rate, here calculated with the usual model, and soil is the soil organic carbon content in the soil, while here is the enrichment ratio. At the same way, we can calculate the soil organic carbon loss under agro-environmental measure. What we have to change is surely the key factor, so the erodibility of soil that depends of organic matter content, and the C factor that depends also by land cover. And now, in order to have that the first equation is higher than the second equation, I want to calculate which is this sock soil max. The next slide. Okay, here are presented the two equations that I showed before, and we have that the red lines represent a function of soil organic carbon loss in relation to sock content, while the green line represents the sock loss in agro-environmental measure. So imagine for a given value of soil organic carbon, the soil loss the soil loses an amount of carbon that here is represented by the by the blue circle. This amount of organic carbon loss is obtained under agro-environmental measure with a soak content that is equal to soak A. For all values that are higher than this soak A in agro-environmental measure, we have a higher soak loss in comparison to conventional tillage. So we have applied this approach. Oh, sorry, because it's okay. We have applied this approach in Sicily in this real case study using 100 paired sites. Each paired site is composed by 2 vineyards where they are similar in all aspects and except for land management because we have a conventional tillage versus cover crop management. This area covered 150 hectares, and what we have seen was that after 5 years of agro-environmental measure, soil management with agro-environmental measure, we have that 10% of these 100 paired sites have occurs that the carbon loss in agro-environmental measure more carbon in comparison to conventional tillage. So therefore we can say that we have reached the carbon threshold, and we have seen that the carbon threshold was reached after 3 years. Okay, thank you.
So, thank you very much, Agatha, for your presentation. Are there some questions from the audience? Well, I will have a very small question, Agatha. The idea is you presented this kind of more conceptual graphics about the change of soil erosion with soil organic carbon. But do you have also some real figures on this?
Yes.
What is
No.
What are the and is this kind of linear, or is this more a kind of stepping?
These are just the steps, but if we apply in the model, for example, usually, and we change these parameters, such erodibility and just the parameters that are affected by organic matter, and we can see that is not, for example, linear, the erosion rate with the organic matter component. But it's just to understand what's happened when we change something, and if we can reach this threshold that in this graph is represented by the dotted line, red dotted line.
Okay, so thank you very much. Any other question? No, so then thank you again. And let's hear now the presentation of Maria Burguet. Maria, it's your soil 13. Are you around?
Hello, can you hear me? All right, so good afternoon, everyone, and thanks for coming to this talk on sediment delivery distribution in olive microcatchments. Well, one of the main sources of soil erosion in South Spain are olive crops located in mountainous areas. So with this idea in mind, our hypothesis was to test if it was possible to identify the main sediment sources within a watershed. So in order to test it, we propose in this work to study the sediment delivery ratio distribution in 2 commercial olive microcatchments in South Spain. Setenil catchment is located in a mountainous environment and Conchuela in the middle of the Guadalquivir River in South Spain. So you can see like they are quite different watersheds, different environments and stuff. And for the calculations, its watershed was divided into geomorphological units, while taking into account its topographical and agronomical criteria. Then, for each unit, the sediment delivery ratio and the sediment yield were calculated as proposed in set model developed by Ferro and Porter in 2000. In here, beta is a geomorphical parameter which lumps together the effect of the travel time of the sediment particles and the runoff along the channel. And for the model calibration, 5 different runoff scenarios were performed with different erosivity values, which weighed the importance of rainfall versus the concentrated runoff. All right. So the results of this work shows that the best fitted scenario in Setenil was associated to the total erosivity equal to the erosivity of the rainfall. But in contrast, the best adjustment for Conchuela was associated to erosivity values depending on runoff and peak flow. Oh. In this slide, the scatter plots show that Conchuela presented a very good model performance, while Setenil had very poor adjustment, using only the beta median value of the model as proposed by the authors. Nevertheless, the fit improved in both watersheds when the differentiation between positive or negative beta values and their corresponding medians were considered to calculate the sediment yields. For Setenil watershed, the sediment delivery ratio calculations showed that the most efficient areas on sediment transport are those in which rills are formed after rainfall events. But in the case of Conchuela, those areas are located near the gullies. In this work, we propose that sediment delivery ratios greater than 100% mean that the model numerical answer to incorporate sediment losses can be due to either the gully activation and/or channel contributions, and this last includes sediment remobilization within the catchment from previous storm events. To conclude, we can say that set model allowed us to identify the areas prone to erosion within a watershed, and at the same time, this work allowed us to propose a calibration strategy based on separating beta values, positive or negative, in order to adjust in a better way sediment loads are corresponding to dataset outliners measured in our watersheds. Yep. So thanks a lot.
So thank you very much.
Thank you.
Oh. Thank you very much again. We had here some sound problem now.
Oh, sorry.
Is there any question in the audience? I have to admit, it seems to be that the avatars have been drinking beer or something like that. They do not have questions.
Oh, that's good then.
Anyhow, I have a question. If you go back 2 or 3 slides, well, that's my function as a chairman now. If you can go back 2 or 3 slides where you have these regression curves.
Yeah, give me 1 sec.
How reliable? Yes.
All right.
This one, yes.
Yeah.
How reliable do you think is your data, especially as most of your data is skewed on this left side of the graphs, where you have a real dense point cloud, and only some data are going to the right that are making your regression lines then really acceptable. So what do you think about this data?
We at the beginning we thought that they were like outliners of our data, because like the soil losses in there are very high compared to the rest of our data set. But then, as we did like cloud graphs to see the behavior of the little events, you can still see the trend. Although I'm not presenting those data in this presentation, but still I'm proper confident on the data measured and on the data released by the model.
Yeah. Anyhow, I think that it's with this kind of data not really valid to make this kind of regressions, because I would like now to have something to show on the on the screen. As you see, we have a big point cloud on the left side, on both, especially in Sentinel, this is visible. So you will always get a nice R squared as you have your point cloud with the small values, and you have then a very nice line with the big values. And it's of course that soil erosion is based mainly on the big events and not on the small ones.
On small events,
So I think that's simply a kind of problem of the, in my opinion, of showing that this is a statistical relationship or between the observed and predicted sediment loads. I think there is almost no relationship when you see the data.
Well, but still, like when we did the cloud graphs, you know, when we try to separate small events and those kind of big events, obviously the square R was not as high as the one presented here, but still you could see the trend. Am I explaining myself?
Yes, this is a very good explanation, really. Many thanks. So
that's all right, thank you.
Are there some other people with more friendly questions? So, okay.